Hello, today we're going to discover the number of lines of symmetry in a figure. Now, as a reminder, here are some examples of figures with a dotted line drawn through it. Those dotted lines represent the line of symmetry. Now notice, I'm going to highlight a few of these. For example, this line right here, this dotted line going through this figure, notice there's the exact same amount of the figure to the left and the right of that line, almost where you're separating that figure into two equal pieces. Or if you were to fold on that dotted line, you're going to find that it's an equal amount on both sides and that figure would go right on top of it. That's forming a line of symmetry, and that's proving that that figure is symmetrical. Now, as you take a closer look at each of these figures, your line of symmetry can be diagonal, horizontal, or vertical. Now this figure here, we have a dotted line or a horizontal line representing the line of symmetry. If I look above and under, I find that there's an exact same amount of that figure above and under that line, proving that this figure is symmetrical. Now some of these objects that you see, there might only be one way to draw this line of symmetry, and if you draw that dotted line or that line of symmetry in another direction, it's not going to prove that it's symmetrical, and you're going to find that you might not have equal parts on both sides. Your goal when determining where that line of symmetry goes is to look for a spot in that figure where you can break it into two equal parts. Now in these examples here, some of these figures might have more than one line of symmetry, and that's absolutely fine. In fact, that's what I want to focus on today. So notice here we have an isosceles trapezoid. Now in this trapezoid given, there's one line of symmetry. There's only one way we can break this into two equal parts, by drawing a vertical line. But some figures, such as this rectangle here, can be broken into two equal parts with a vertical line and a horizontal line. Now this is proving that in this rectangle there's not just one line of symmetry, there is two lines of symmetry. So today I want you to really take a closer look at the given figures and determine how many lines of symmetry you can find in that figure. Now, as a reminder, a line of symmetry divides a shape into two regions that are mirror images of each other across the line. So for example, here we have a heart. And notice this heart, we drew a vertical line right through the middle of this heart, forming my line of symmetry. And I want you to recognize that this is dividing this heart into two regions that ultimately mirror each other. And notice it's the exact same amount of the figure on the left side and the right side of this heart. But in this picture here, we also have a heart, and I see that another line is drawn through it. But this line is not a line of symmetry, because if you look to the left and to the right or above and under this line, you're going to find that you do not have the exact same amounts. Therefore, this line is not a good representation of a line of symmetry. In fact, that is not a line of symmetry. So you have to be very careful where you're placing this line of symmetry to determine and prove that this object is symmetrical. Now again, we're going to look at this shape. Here we have a rectangle. As a reminder, to find a line of symmetry, look for two halves of the rectangle that are mirror images of each other. The line of symmetry of a rectangle each pass through the midpoints of two opposite sides. So notice here, this is my midpoint of my length, and this is my midpoint of my width. And notice my horizontal line is passing through the midpoint, or that middle region, of both my widths, and that green line is forming one line of symmetry. But now if I look at my lengths, if I look halfway, called my midpoint, exactly halfway down that around that length right over here, you're going to find that this line is going right through this midpoint and this midpoint, forming a vertical line, and that is also called my line of symmetry. Now there are no other ways to split the rectangle so that the halves are mirror images of each other. So the rectangle has two lines of symmetry. So today I want you again to take closer looks at these figures given to you and determine, is there more than one line of symmetry? Now again, to find a line of symmetry, look for two halves of the rhombus that are mirror images of each other. In this rhombus here, you're going to see that there's two lines of symmetry. The line of symmetry of a rhombus each pass through the opposite vertices. In other words, the line of symmetry are the diagonals. Now here and here are two vertices, but we also have another vertices here and here. And notice that vertices is where two rays meet at the vertex, and that's forming that angle. But now together, if we put these angles together, we're actually forming a rhombus, and that's forming a shape that's made up of four angles and four sides. Now each angle here, this is a vertice, this is a vertice, this is a vertice, this is a vertice. And now look at this purple line. If we connect one vertice to the opposite vertice, that's forming that diagonal line, which is also known as my line of symmetry. And I'm also going to do the same thing for the green line. I have one vertice here, one vertice here, and I'm forming that other diagonal line. So there are no other ways to split the rhombus so that the halves are mirror images of each other. So the rhombus has two lines of symmetry. So today I really want you to take a closer look at these figures and determine, is there one line, two lines? Many of you might recognize there's one diagonal right away, but there could also be another diagonal representing that line of symmetry as well. Now in these figures here, it says how many lines of symmetry does each shape have? And you're going to fill in the table, which I actually filled in this table here, but I want to discuss why I filled it in with specific numbers given. Now here we have an ellipse, or you might say it looks like an oval. Now line of symmetry is 2. Now right away I do recognize, okay, let me draw a vertical line here. And right away it's breaking it into two equal pieces. The left and the right have the same amounts. But I can also draw a horizontal line here. And that's also breaking it into another two equal pieces above and under, which is why we have two lines of symmetry. Now this figure here, this is actually a square. Unlike the rectangle we had before, there's 4 ways to show a line of symmetry. Now similar to the rectangle, you can draw a vertical and a horizontal line, but you can also draw diagonal lines as well. Because remember, line of symmetry can be horizontal, vertical, or diagonal, which this is why we have 4 lines of symmetry. Now we have an arrow. If you were to draw a vertical line right through this arrow, you're going to find that to the left and the right of it, you have different amounts. So instead, I'm going to take a closer look and think about if there's another way I can do this. So let's try a horizontal line this time. And by drawing a horizontal line, I find that we have exactly the same amount above and under. Therefore, there's one line of symmetry. Now here in this parallelogram we have, unfortunately, there's no lines of symmetry. If I tried doing a horizontal, vertical line, diagonal line, and even if I drew this figure on my piece of paper and folded on these potential lines of symmetry, you're going to find that there's not an equal amount on both sides. And that goes the same for this object here as well. I encourage you to draw this on your paper and learn and discover that it's not going to work wherever you draw that line of symmetry. If you fold your paper, you're not going to get 2 equal halves. Now we have a rainbow, which I think is so amazing. This rainbow here, if I draw a nice vertical line, I can find that I have exactly 2 halves, and same with my heart, just like the example I proved before. Now, when you're looking at these figures today, again, it's very important to take a close look at the figure and determine how many lines of symmetry you can identify. Feel free to look back at this video at any time to help you discover and help you identify and learn how to represent and draw these lines of symmetries.